All right, good afternoon, students. Today I'm going to show you how to graph simultaneous equations without making a table. Because I know at this point in this week of all the stuff we've been doing, I know for a fact you guys are fed up to here with making tables. So I'm going to show you the quick and easy way to not only find the point of intersection, but to also make your lines really, really fast. Here's the trick. All our equations up here you see are in slope-intercept form, which means they are in the form of y equals mx plus b. M is our slope, and b we talked about is our y-intercept. That is probably some of the most important information you can get when you're making your lines. Now, here's our first example. We have a y-intercept of -4. That means I have a line that crosses this y-axis at -4. So if I go to 0, 1, -1, -2, -3, -4, then that means I have a point there already. So without making a table, I've already identified my first point in my line. But now I need more than 1 point. You need at least a minimum of 2 points to make a straight line. So I look at my slope. My slope tells me my rise over my run. That means whatever point I have on my line, I can go up 1 and over 2 to get to the next point. So for example, my y-intercept was at -4. That means if I go up 1 over 2, I get my next point. Up 1 over 2 again, I get my next point. And I can keep repeating that same process and get every single point on this line without ever having created a table. Once I have that, I will go ahead now and I will line up all my points with my straight edge, and I will attempt to make a straight line through all these points. And I managed to do that successfully, surprisingly. So here is my first line. This is the line of y equals 1/2 x minus 4. Now I'm going to switch colors and go ahead and work on the second line. And the trick is the same thing again. I will first identify my y-intercept. In this case, it's +2, which means I will go 2 spaces or 2 units above the origin and plot a point. There's my first point of my line. Now I look at my slope. It looks like it's hidden because you're wondering what's -x. -x really means -1 times x. So my slope is -1. Make -1 into a fraction, it's -1 over 1. That means instead of a rise, I will be going down 1 unit, and then I'll go over to the right 1. So down 1, run 1. So from this point, I go down 1 box, and then to the right 1 box. Down 1, over 1, down 1, over 1, down 1, over 1. And I repeat this process until I have sufficient number of points to make my line. Now that I have all my points that I want for now, I'll go ahead and take my straight edge again, and I will make a line that goes through all these points. And I can see already that I have a point of intersection. My point of intersection appears to be right here at 1, 2, 3, 4, comma, -2. Now, it looks like that's my intersection point, but because I didn't do any tables to prove it, I'm going to have to prove it by actually doing the math. So I'll go ahead and take this 4 from my suspected solution and plug it into my equations. So my first equation said 1/2 of x. The x I'm going to use is this 4 right over here. So 1/2 of 4 minus 4. And then my next equation says -x. Negative, the x I'm going to plug in is that same 4 plus 2. So now let's go ahead and do the math. Half of 4 is 4. Half of 4 is 2. Minus 4 is -2. -4 plus 2 is also -2. So I just proved that this is truly my point of intersection. So both graphs intersect at 4, comma, -2. That was pretty fast and easy, but let's go ahead and make sure we really know how to do this and try this again. So I will move over here to my second graph. Here I have 2 different equations. Y equals -2/3 x plus 2, and then I have y equals 2x minus 6. Once again, let me identify my y-intercept from the first equation, which is at +2. So I go to my y-axis, and I find +2, and I plot a dot right there. Now I have my slope of -2/3. If you have a negative slope, that means the negative sign goes with your numerator, so it's down 2 over 3. So starting from my first point that I plotted, I will go down 2 over 3, down 2 over 3, down 2 over 3, And you can keep doing that until you have enough points to create your straight line. I'll go ahead and take my straight edge now and graph as best I can this line. And it kind of didn't hit at the end here, but that's okay. I got the bulk of it on the lines. Yours will look a lot better, obviously, because you'll be doing yours by hand on paper. Now, my second equation is y equals 2x minus 6. My y-intercept I've identified as -6. So let me go ahead and change the color up a bit to get some contrast. -6. So from my origin, I will go down 1, 2, 3, 4, 5, 6, and plot my point at -6 on the y-axis. Now, my slope is 2x, or actually 2. Make it into a fraction, 2 over 1, which means I rise 2 and run 1. So from this point I just did, I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and I can continue that pattern indefinitely until I have enough points to satisfy so I can make a straight line. And I already have enough points, so let me go ahead and line them all up with my straight edge and then connect them all. And as we kind of see, I was a little bit off the mark, but I'm more or less right there. My point of intersection appears to be at 1, 2, 3, 0. But I can't really tell, maybe because my graph's kind of messy. So I need to verify if that truly is the correct point. So I'm going to plug in this 3 for my x values in this equation up here and down here. Let me clear up my screen a little bit so we can see the original equations again, and I can prove if this indeed is the intersection. So I'll take -2/3 times my x value over here, which is 3. Then I'm going to add 2. Then I will take 2 times, and then I'm going to use the same x value, the 3, and subtract 6. Let's see what I get. -2 times 3 is -6. -6 divided by 3 is -2. -2 plus 2 is 0. I get a 0 for my first equation, just like I wanted down here. 2 times 3 is 6. 6 minus 6 is also 0. So because I get my double zeros, or I get the same answer, I know that this indeed is my point of intersection at 3, 0. Now you're going to have a practice set of problems to work on the rest of the class to practice this. Good luck, guys, and raise your hand if you have any questions. Thank you very much.